Hi everybody, this is Ms. Faina. Today we're going to be talking about exponential functions. So our exponential equation is going to be ab to the x power. Okay, so how we know it's exponential is the x is the exponent. So again, this is our exponent. Okay, so the a is going to represent the y-intercept. Our starting value, or the initial amount. Okay, the B is going to represent the growth or decay factor. Okay, so if B is greater than 1, we call that exponential growth. Okay, so an example of an equation that would look like that would be y equals, let's say, -2, which would be the a, times 5 to the x power. The number 5 is greater than 1, so therefore it is exponential growth. Okay, now if b is between 0 and 1, so not negative, it means anything between 0 and 1, like 1/2, 0.1, 0.2, 1/4. Okay, that is called exponential decay. An example of what that would look like would be y equals, let's say, 3 times 0.25 to the x power. Or it could be y equals 3 times 1/4 to the x power. Okay, it doesn't matter if it's a fraction or decimal, it just has to be between 0 and 1. So 0.25 is between 0 and 1, and 1/4 is between 0 and 1. Okay, and then another important thing is blank is for the base b. Okay, that's our base, and it always has the exponent of x. So looking at our first examples, we want to identify a, b, and we want to determine if it's growth or decay. Well, remember, it's y equals a times b to the x power. So a is going to be the number 3. B is going to be 7/2. Now, to help determine if it's growth or decay, it might be helpful to change the the fraction to a decimal. So I'm going to switch over to the calculator, and I'm going to type in 7 divided by 2 and put a decimal point and see that it's 3.5. So B is either 7/2 or it's 3.5. Well, that number is bigger than 1, so this would be exponential growth. Okay, looking at number 2, we have f of x equals 3 times 2/5 to the x power. Again, y equals a times b to the x power. So my a is 3, b is 2/5. Again, just to see, I'm going to go ahead and change that to a decimal. So my calculator, 2 divided by 5, I'm going to put a decimal point, and I get 0.4. Okay, so 2/5 and 0.4 are between 0 and 1, which means it's exponential decay. Okay, looking at number 3, I have h of x equals -6 times 2 to the x. If you want to, you can put parentheses around the 2. Okay, it's the same thing. But again, we have y equals a times b to the x power. So my a is -6. My b is a +2. Because 2 is bigger than 1, it's automatically growth. And we don't need to worry about changing it to a decimal because it's a whole number. Okay, looking at example 4, I have j of x equals negative, and then in parentheses, 1/3 to the x power. Remember, again, y equals a times b to the x. If there's not a number there, but there's a negative sign, that means it's a 1. So my a is -1. My b is 1/3. Okay, So if we switch that over, I do 1 divided by 3, put a decimal point, I get 0.3 repeating. Okay, so it's equal to 0.3 repeating, which means it's less than 1, but it's bigger than 0, so it's between 0 and 1, so it is decay. Looking at the next one, now we're going to write the equation. So it says, what is the equation of an exponential function if a is 4 and b is 3/4? Okay, so again, my form is y equals a times b to the x power. So I have y equals 4 times 3/4 to the x power. 3/4 is less than 1, so this would be decay. That's just a little bit extra, but this is our actual equation right there. Okay, looking at number 6, what is the equation of an exponential function if a equals, oh, this is the same exact numbers, right? It is. So I'm going to go ahead and change, let's see. Let's make a -2, and we'll make b, let's just switch it to 4/3. Okay, so I have y equals a times b to the x power. So my equation, y equals -2 times 4/3 to the x power. 4/3, we change that to a decimal. We get 1.3 repeating, so that would be growth. But again, it just wanted the equation. Okay, looking at the next part, the graphs. Okay, so we have a graph here. We want to know the y-intercept. Remember, the y-intercept is on the y-axis. So that's right here. That's also the a value. So my y-intercept is 4. So we can either write it as +4, or we can write it as a point, 0, 4. And if I notice, it's going up like it's a roller coaster. Okay, so that is going to be growth. Looking at the second one, okay, my y-intercept again falls on the y-axis. So it's right here. That is 3, or 0, 3 if we write it as a point. Now this is going down like you're going down a water slide where you get a wedgie at the end. Okay, that's going to be decay. So if it looks like it's going up like at the start of a roller coaster, it's growth. If it looks like you're going down a slide, that's going to be decay. Okay, now number 9 wants us to write the equation of an exponential function. Okay, but we're given a table now. So we've done stuff like this before. We're going to use our calculator, and we're going to use the Listing Spreadsheet. So we've done this a few times. Oops, made a spelling mistake. Okay. But instead of doing 413 or 416, we're going to do menu 41 and the letter A, and it's going to say exponential. So I'm going to go ahead and go over to my Listing Spreadsheet. So my calculator, I'm going to go home, new document. No, I don't want to save. And I want to add a new Listing Spreadsheet. Okay, so I'm going to lay my notes on top so we can see the table. Remember, next to the A, we type in X. Next to the B, we type in Y. And then I'm going to type in my table. So I have 0, 1, 2, 3, and 4. And then for my Y's, I have 1, 2, 4, 8, and 16. Okay, so I'm going to go to menu, the fourth one down, which is statistics, the first one, which is stat calculations, and then letter A on the yellow calculator, it's going to say exponential regression. So when we deal with linear functions, we do linear regression, mx plus b. When we do quadratics, we do quadratic regression. Now that we're talking about exponential regression, we're going to do exponential regression. Okay, and we've been here before. X list, we type in X. Y list, we type in Y. And then we hit OK. So what we're looking for is for A and B. So right here it tells us that A is 1. So A is 1. And it tells me that B is 2. So I can write my, oh, I just wrote B. My B is 2. So I can write my equation. Y equals 1 times 2 to the x power. Or you could see it as just y to the 2x power. Okay, oftentimes if it's a 1 for A, we don't write it, but it never hurts to write it so you can see that that's the A in the y-intercept. Okay, so looking at the next one, again, I'm going to use the listing spreadsheet, but I'm going to go ahead and start over. So I'm going to do a new listing spreadsheet. I'm going to type in X next to A, B next to Y, and then I'm going to go ahead and type in my points. So I have 0, 1, 2, 3, and then my Y values, I have 1. For 1/4, I'm just going to do 1 divided by 4 and press enter. Okay, I don't know if you can use the fraction, so let's see if we can use the fraction button. So 1/16. So yeah, you can use the fraction, but it just turns out the same way. And 1/64. Oops, I put 1/16 again. So 1 divided by 64. There we go. I have the right thing. Okay, so I'm going to type in menu, the fourth one down, statistics, the first one, stat calculations, and then letter A, which is exponential regression. Okay, next to the X list, we're going to type in X. Next to the Y list, we type in Y. And then we hit OK. So we're looking for A and B. So again, my A is 1. My B is 0.25. Also know that 0.25 is the same as 1/4. So your equation, y equals 1 times 0.25 to the x power. You could have 1 times 1/4 to the x power, or remember, you might not see the 1 and it might just be 0.25 to the x power, and lastly, or 1/4 to the x power. All 4 of those mean the exact same thing. Okay, so I'm hoping that after watching this, we've learned a little more about exponential, or we refreshed our mind. So remember, again, this is our formula for our equation, where A is the y-intercept starting value or the initial amount. So the important part is to know A is the y-intercept or the initial amount. And then B tells us if it's growth or decay. Remember, when it's greater than 1, it's growth. When it's between 0 and 1, that does not mean negative, because B cannot be negative. It is decay, and B is our base. So it's always going to have the X as the exponent. So if you have any questions, please write them down. Ask your teacher. We're here to help you. Other than that, have a great day, Rain.